Welcome back to Module 9.5. In this lecture video, we're going to talk about using linear equation to solve word problems involving with something called the consecutive integers. So there's two kinds of consecutive integers here. One of them is just a regular consecutive integers. The other one is called consecutive even or odd integers. So let me explain this a little bit real quick. Consecutive integers means integers that are back to back. So for example, if I start out with an integer 2, the next one got to be 3, the next one got to be 4. So if I want to travel from 2 to 3, then all I got to do is add 1 to it. All right. If I'm starting at 2, trying to get to the third integer, I must plus 2. So the way we're going to set this up is always called the first integer n or x. The next integer will just be the first integer plus 1. Then the next one after that, the third integer, got to be x plus 2, right? Plus 2 to reach the third consecutive integer. So what these things are the way what we are the things we're going to use for the three integers. So sometimes the problems will call them the first, second, and the third integer. Sometimes the problem will call them the biggest integer is x plus 2. The smallest one is going to be the x. Those are the wording that we may run into dealing with the word problems. So make sure you memorize this, okay? You got to memorize the way how you're supposed to set up. For consecutive, even, and odd, so I'm going to write it down, okay? Consecutive even integers. If I start out with the first even integer as 2, the next one got to be 4. The one after that got to be 6, right? If I start out with consecutive odd integer, like the first one to be 3, the next odd integer is 5. The next one after that got to be 7. All right, so if I starting out with 2, travel to the next even integer, I got to plus 2. If I start out with 3 as the first odd integer, to travel to the next odd integer, I also plus 2. So you see the even and odd, consecutive even and odd integers has the same setup. So if I'm starting out with the first even integer to go to the third one, I got to plus 4. Start out with the first odd one to reach the third consecutive odd integer, I got to also plus 4. So the setup for consecutive even and odd are the same. Like the first one to be x, the second one, the next consecutive even or odd will always be the first one plus 2. Okay, the third even or odd integer got to be always the first one plus 4 to reach the third one. Okay, so let's try some example. Okay, I normally like to label what I got. This particular example says the sum. Ooh, translation words. Sum means adding. The sum of 3 consecutive integer is 117. All right, so what you look for here is the wording. I'm dealing with 3 integers. What kind of integer? 3 consecutive integers. So the problem does not say the word even or odd. So that must be this first one. 3 consecutive integers. So I'm going to say the first one is always going to be x. The second one always going to be x plus 1. Right? That's the way how we roll it out up here. And the next one, the third one, will always be x plus 2. So the sum of the 3 means the way we're going to write out the equation is take the first one plus the second one plus the third one. Together, the sum of all 3 of them means equal sign 117. All right, so that's the way. So the problem does tell me how to write out the equation. Our job is simply translate for each items. So remember now, I'm going to purposely do this, okay? So I'm going to use red. The red plus sign is referring back to the word sum. All right, first integer, remember, was x plus the second integer, the sum of 3 of them, My second integer is x plus 1, right? So these two terms is representing the second integer plus the third one is x plus 2. So basically, I still have the same three integer or the same three term on the left side. It's just when we translate them, okay, the second term or the second integer is now become x plus 1. The third integer is now x plus 2. Together equal to 117. Okay, so I reuse the red plus sign to separate, okay, what these two terms, who the two term represent to, or the one term represent to. Now, when it comes to solving, I'm just going to view this as a regular equation. Okay, x plus 1 plus x plus 2 on the left side. So I got 1, 2, 3, 4, 5 different terms on the left side when it comes to just solving the equation. So combine like terms, x plus x plus x give me 3x. All right, if I combine like terms here, that will be positive 1 plus 2, which is positive 3 on the left, equal to 117. All right, so since my variable term is positive on the left side, I'm going to let it stay. So that's still 3x. Let's move my positive 3 over, so that becomes negative. So that's 117 minus 3, which we know that's 114. So to get x by itself, I divide both sides by 3. 114 divided by 3. Voila, 38. So now, x equal to 38. But think about, what does x represent in this word problem? X representing the first integer. That's why I wrote this down initially, so I know who represent what. So my first integer is 38. So the next consecutive integer is simply plus 1. That will be 39. The one after that got to be integer 40. So these three numbers, these three consecutive integers are your answer. All right, let's take a look at this one. Okay, I got this one here, the sum of two consecutive integers. So this time I'm only dealing with two integers. Two consecutive, what kind of integer? Even integers. So that's the word, I'm going to highlight the word even. Okay, so I have the first even integer and the second one. And let's look back up to the top. What's my setup for the even integer? We're always going to let the first one to be x, the next one to be x plus 2. That's why I said earlier, memorize the way what the first, second, and third one should be. It coming handy right here. First one is x, second one is x plus 2. The sum of them two is negative 222. So that means I take my first integer plus the second integer together equal to negative 222. So in a way, the equation already told me how to write it out, the equation itself. Our job is to translate for the individual items. All right, I'm going to put a plus sign right here, okay? So my first integer is always x plus my second integer. You cannot just say 2 right here. This is wrong because the second integer is actually x plus 2. The first one is 1, it's already a x. The second one is actually x plus 2. So these two terms represent the second integer. So just be careful. All right, you got to equal to negative 222. All right, now let's solve it. Just when we solve equation, we just look at this equation like a regular linear equation. X plus x is 2x. Still got positive 2 here, equal to negative 222. Now I need to move my positive 2 over, since my 2x is already positive, and that's the only variable term I got. Let it stay there. So that's 2x equal to negative 222. Positive 2 come over, become negative. I wrote it down, so since there's so many 2's here, kind of confusing. So that's 2x equal to negative 224, right? Term with the same sign, we add. So when I divide both sides by 2, my answer, x equals negative 112. So that's a good news because negative 112 is an even integer. So I'm doing something right. So x represent first integer. So my first even integer is negative 112. Be careful. The even integer, the next one to the right, or the next bigger one. You got to remember the first integer is always the smallest one. So the next bigger integer is not negative 114. Negative 114 is actually smaller. On the number line, number that are bigger is always to the right of it. So the next one would be negative 112 plus 2, which is negative 110. Okay, those are your two consecutive even integers. All right, let's try this one. This is a sum of 3 consecutive odd. So dealing with 3 consecutive, what kind of integer? Odd integer. So when it says even and odd, my setup is the same. When it does not say even or odd, that means it's the regular consecutive integer, which the setup is x plus 1, x plus 2 up here. Even and odd is always x to be the first, x plus 2 to be the second, x plus 4 to be the third. All right, so the sum of them 3 is negative 333. So we take the first one plus the second one plus the third one together equal to negative 333. Okay, let me write the plus sign. So my first one was x, second one x plus 2, third one x plus 4. Together equal to negative 333. All right. Now let's just solve for this regularly, okay? Combine like terms. X plus x plus x, 3x. Combine like terms, 2 plus 4, positive 6, equal to negative 333. All right, since my variable term is only 3x, it's positive on the left, I'm going to let it stay. Move the positive 6 over. I get 3x equal to negative 339, right? Negative 333. Positive 6 come over, become negative 6 or minus 6. That'll give me negative 339. Divide both sides by 3. My answer, x equals negative 113. So that's good. That's good news because that's an odd integer. So that means my smallest consecutive odd integer got to be negative 113. The next one to the right of it, if I plus 2, it'll be negative 111. Be careful now. A lot of people say, oh man, plus 2, man, that would be negative 115. Come on. Negative 113 plus 2. Term with a different sign, we subtract. So negative 111 is actually bigger than negative 113. So the one to the right of the second one got to be negative 113 plus 4. Okay, so do 2 more, that'll be negative 109. Okay, if you don't believe me, take negative 113, which is what the x was, plus 4. All right, negative 109. So these 3 are my consecutive odd integer. So in this lecture video, I demonstrated how to translate for the consecutive even odd integers or just the consecutive integers. So as long as we can translate for the items, normally the problem already told me how to write out the equation. Our number one job is translate for the items that are described in the problem. So by understanding consecutive integers or consecutive even odd integers, hopefully it will help us comprehend the next objective in this particular module 9.5, which is something I like to call the comparison problem. All right. Thank you for watching. That concludes this lecture video.